Hello everyone. Welcome back to the day 8 of our series Inventing Stuff with Ardino in Tinker CAD by Sanyo. So as I promised you that in today's session I will make you learn how to make a obstacle detector, and I will also tell you its coding, its functions, everything, and it would be very interesting. So let's begin. And first of all, I also need to make you learn about the PIR sensor, that is also known as the motion sensor. Okay, so first of all, the modern name for the PIR sensor is HCSR04. Sorry, 05. So 04 is for ultrasonic distance sensor. For the motion sensor, it is HCSR05. So it is not coming because in Tinkercad it is not saved by that name, particular name, but in the real life it is this only. Okay, so this is what a PIR sensor looks like. Okay, so what it does is inside this there is a sensor named pyroelectric sensor. So that sensor also help it to detect motion and carry out the functions. So we will not go so much deep into the theory part. We will only learn some amount of that and then we'll do the practical thing. Okay, so the pyroelectric sensor help it to detect the motion, and as soon as it detect the motion, the component connected to us, the signal pin, see this signal, it becomes high, and this power and ground is for just activating this PIR sensor. So let me just connect the Arduino. Let me just bring this here, and now I will just connect the signal pin like this. Then power I'll connect with the 5 volt. So here my circuit is done. Now let's come to the coding part, and in this, this is the basic circuit first. So what we will do is we'll just print the values of the PIR sensor. Okay, so let's define sensor is equals to, so it's connected to pin number 8. So I'll write 8. Then void setup, and let me also zoom this. Okay, so now I think you can see it properly. Now this is the void setup going on. So now I will write here we have to give the pin mode. So I'll give the pin mode. So the pin mode for this will be input, as it is a sensor. So every sensor, that has some values. So that's why we keep it as input. So now we'll come to the last part, that is void loop. Let me take it down. Now we'll make an empty variable, let's say key, and now we'll go down and we will do keys equals to digital read, and we need to read the sensor, the PIR sensor. So here I am writing sensor. Now I will start the serial monitor by writing serial.begin 9600. And I'm reminding you again that please drop your feedback. I haven't received so many feedbacks till now, so please drop your feedbacks in the email or in the comment section, so that I can improve if I am lagging somewhere. Okay, so I'm dropping my email here as well. It is kidscare06 at the rate gmail.com. Okay, this is my email. You all can please note down and please give your feedback at this place, at this email. Okay, so that if you think that I have not covered any part properly, so I will just make a video again and I will put it, I will drop it in my channel. Okay, so please drop the feedback. So now let's get going with our this session. Now I will just write serial dot println key. Okay, let's now start the simulation by resetting. Okay, so now the values are 0. There is no motion. See, okay. So it's like binary language as 0 and 1. 0 means 0 volts, 1 means 5 volts. Like this you can understand, or either 0 means no motion, 1 means there is some motion. See, okay. So this was the basic circuit. Now first let's make the obstacle detector. So in that we are including the Pir sensor. So that will be the task for today. Okay, so now I will write this as J8 and I'll save it. I'll go back and I will click on create new circuit. Okay, so first let's rename this. So the main function, the main motto for this will be that first of all the components we will use is a LDR, light dependent resistor, ultrasonic distance sensor, PIR or motion sensor, and buzzer and a LED RGB. So this would detect the obstacles that comes in between, let's say a car. If we connect this device to a car and there is some motion, there is anything that is in front of the car and the distance is less than 100 centimeters and the motion is there, then what should happen? A buzzer should ring and the LED RGB should turn to green color. And when the distance is more than 100 and there is motion, then nothing should happen because it's enough distance, it's much farther, so it would not harm the car. But when it comes close, then the device that we make should just tell the driver, should just alert the driver for taking some actions for that. Okay, now let's take the sensors one by one. Okay, so now I'll connect the signal pin to pin number 13 and I'll change the color yellow. Power is always connected to the positive side, that is 5 volts. Okay, and the ground is again connected with the ground only. Okay, now we will take ultrasonic sensor, but we need to take the HC SR041. So please make sure that you take this one because there is difference of pin. Okay, so we are going to use this one. Now VCC is again here positive, so let's connect it to the positive. And it's red. Now trig and the echo, they will be connected with the digital pins like this, and the ground again with negative. Okay, and now comes the turn for LDR. So let's take out the LDR, and so with the negative side we take a resistor. So let's make it. Mm, and from here we'll take this wire and connect to positive. This will be red, and this we'll connect with the analog pin. So I think that it would be somewhat complicated for you all, but it's a very useful circuit. So please ensure that you make it. And if you don't understand this, then I have given you my email. It is in the description as well. So please just drop me a message. I'll make a video again explaining in a better way if you don't understand, or you can ask if there are only one or two queries in the comment section. You can ask, so I'll respond there. Okay. Okay, so now we only need to connect the buzzer and the LED. So the buzzer, this negative side will be connected with the negative here. Okay, let's do it straight, and now this will be black. But this one, it would be connected with the positive because we want this to just shrink at alternate times. The time that we want, that time it should glow. So that's why we, to control it, we are connecting it with the digital pin. Now the LED cathode will be connected with the ground. So today we are taking many components together. We are working with many components in one circuit, and there are many more complicated circuits like this that we can work on, but we'll not go with all in this series. So as I promised that I'll start a new series after 1 or 2 weeks, and in that we learn about a new thing, so that is the logic gates. So let me tell you till I'm making the circuit. Till that time, let me tell you that what are basically logic gates. What is the definition of logic gates? So a logic gates are divided into many parts. So the three basic logic gates are and, or, not. So and, or, and not are different. I'm not saying and or not. I'm saying and, or, not. Okay, so these are three different logic gates, and these were used when this Ardino didn't came. So the makers to have control over anything, uh, before the Ardino came, they need something. So they invented logic gates, and every electronical device, everything in this world that use electricity or is a electronical device has logic gate inside it. Even this Ardino Uno has logic gates inside it. It also works with the help of logic gates. Only the difference is that the logic gates that we learn, that is and, or, and not, that cannot work with the coding. We cannot handle them with the coding, but Arduino we can handle with the coding. Only this much is the difference. Otherwise, they both have logic gates. They are mostly same. So now our circuit is done. Now let's define this, and let me just zoom this. So our first, the PIR is connected to pin number 13. Then our trig of the ultrasonic sensor, it is connected to, oh, just a second. I zoomed it a little bit more. Let me just reset it. Let me just do it like this. And so first I'm writing the code, then I'll zoom it, and for 5 minutes I'll show you so that you can have a look at it completely. Now echo is connected to pin number 4. Then our buzzer is connected to pin number 2nd. Then our blue LED is connected to 1. And I am telling you one thing, that please don't use this 0 pin, because you can see there is TX and RX written. So this TX and RX, these are the arguments of the Bluetooth. Okay, so these are, if we connect a Bluetooth device with this, so that time these pins are used. One you can use, but don't use 0. And one more thing that I am going to cover is, you can see the special sign, and here you can see digital PWM and this same sign. So this is the sign of PWM pins. PWM stands for pulse width modulation. So the makers were very smart, and they gave the users a nice option. So that was, here you can see the analog pins. They are only 5. They are very less. I don't know why it is getting zoomed again and again. Just a second. Okay, so they are only 6. So if we want more than 6, like in a project, if we use many analog devices and we want more analog pins, then what can we do? So we have 14 digital pins, and digital components are not more precisely used, as I told you. Okay, means they are used, but not so much. Mostly sensors are used, and most sensors are analog based. So in that condition, they make these pins that are, let me mark that are 11, 10, 9, 6, 5. So these are 5 pins in total. So these pins with the sign of this, these can be used both as analog or digital. So if you'll write in a digital read, then also it will work. If you'll write analog read, then also it will work. Okay. And in analog pins, you can control the amount of voltage. Like if we write in digital pins low, it's 0 volt. And if we write low, then it's 0 volt. And if we write high, then it's 5 volt. Only these two values we can control. But with analog, we can control it. So it has values from 0 to 225. So if we write any value in between this, so like let's say if you just write 100 or 150, so 150 I think is around approximately 3.3 volts, or it's 3 volts. So like this you can control the voltage, amount of voltage according to your requirements. So you don't need to connect a resistor with that. From the resistor, I remember, I just got to know that we need to connect the resistor here. Okay, please make sure you connect it. Okay, so now let's come back to the coding part. And today we had covered many topics. We talked about many things, and this a big, huge project we are also making.